All right, last question 6, FRQ 6. As usual, any mistakes there be in the description below or corrections. Medication is administered to a patient. The amount of milligrams of the medication of the patient at time t equals hours is multiplied by y equals a of t. That's how many milligrams is in that person. Satisfies this differential equation. Initially, there are 0 milligrams of the medication in the patient. A portion of the slope field for the differential equation is given below. Sketch the solution through the point 0, 0. So you just kind of like follow. It's going to be very steep, then it's going to get more shallow, and then it's going to kind of like that. Okay, because it starts to that point and just kind of connect the dots a little bit. Part's easy. Correct units explain the meaning in the context of this the problem is that's weird. There are no milligrams. This is saying that eventually, if you wait long enough, there are 12 milligrams. Okay, a total of 12 milligrams of medicine is in the patient's bodies, body. Basically when it's done injecting medicine, I guess. Yeah. Yeah. After enough time. So it's like administering it over time, and eventually it approaches 12 milligrams total. Use separation of variables to find the particular solution. That means we have to find with that initial condition. So we're going to move the dt up. I'm going to move the 12 minus y down. I'm going to integrate both sides. I'm not putting an absolute value because I know y is less than 12 in our solution. Because you see that graph, I know why. I would need to put the absolute value if I thought for some reason the solution was above where y was greater than 12. So I don't need the absolute value sign there. Okay, and then e to the both sides to get rid of the natural log. But we're used to writing this as c e to the 1/3 t, right? Which means then you can solve for y. Y is equal to 12 minus c e to the 1/3 t. That's the general solution. The particular solution means that when t is equal to 0, y is equal to 0. So that means 0 equals 12 minus c e to the 0, which is 12 minus c. So c is equal to 12. So your y is simply equal to 12 minus 12 e to the 1/3 t. Yeah. Why is it 1/3? Shouldn't it be negative? This solution is like, it's sort of going downward. It's kind of weird why this is positive. I'm a little confused here. Did I mess everything up right? Because I feel like the solution should have a negative exponent, not a positive exponent. So I'm a little wary of this. But it's 12 minus y. Oh, there's a negative sign when I integrate this. Because I skipped over the u substitution, so it's really negative of this. You can't negative of that. That means when I multiply through by -1, sorry, I apologize for that. I multiply through by -1, there's one more step in here that I should have done. And that is ln of 12 minus y is equal to -1/3 t plus c. And then you can do 12 minus y is equal to e to the minus 1/3 t plus c, which is, so basically the exponent becomes negative here. And everything else is the same. Okay, awesome. That makes more sense. That's what the solution should look like. Okay, different procedure used to administer the medication of the second patient. The amount of milligrams of the medication of the second patient times t hours modeled by the function and satisfies the differential equation. At time t equal 1 hour, there are 2.5 milligrams of the medication of the second patient. Is the rate of change in the amount of medication in the second patient increasing or decreasing at time t equals 1? So we want to know if the rate of change is increasing. Whatever you want to know, if you want to know something is increasing or decreasing, you take that rate of change and you take the derivative and decide if it's positive or negative. So the rate of change is given by this. dy dt is equal to 3 minus y over t plus 2. I want to know if this is increasing or decreasing. So if I want to know this is increasing or decreasing, I take the derivative of this to see if it's positive or negative. So that means the second derivative of this is derivative of 3 is 0. Derivative of this, I have to do quotient rule. So I'll put the negative sign in front and then do bottom, which is t plus 2 times the derivative of the top, dy dt, minus the top times the derivative of the bottom, which is 1, divided by bottom squared. Okay? And so this is negative t plus 2. I'm going to distribute this negative dy dt plus y over t plus 2 squared. And I really care about the sign of this. That's what I really want to know, whether it's positive, whether it's negative. So at t equals 1, we know that y is equal to 2.5, which means we know that dy dt at that point is equal to this, 3 minus 2.5 over 1 plus 2, which is 3, which is 3. Man, they made this really annoying. This is 5 over 6, 3 minus 5, 6, which is 18 over 6 minus 5. It's 13 over 6. Okay, and let's plug that into here. So evaluated at t is equal to 1, then we get negative 3 dy dt, which is 13 over 6, plus 2.5 over 3 squared. I just care about is positive or negative. This is 39 over 6. 39 over 6 is like, or negative 39 over 6 is like negative 6. So this is less than 0. So it's definitely decreasing. So we say decreasing at that point. So that means that dy dt is decreasing. Oops. All right. dy dt is decreasing. Okay. Yeah, any questions or comments, just leave them in the description below, or leave a comment if you have any questions on it, or if I did anything wrong.